workshop will be hosted by Cody Shaner. Cody is a web developer and a boot camp instructor at NuCamp. He enjoys learning about technology and working with it, and today he will be leading a workshop called Objects and JavaScript, A Closer Look, where he will be doing a deep dive into JavaScript objects so you all can gain a deeper understanding of how they work and what you can do with them. So I'm gonna pass the mic to Cody.
Well, sweet, thank you. Can everybody hear me all right? I hope so, think so. All right, so first off, the purpose that I was wanting to do this was, I think, the true nature of JavaScript's sort of object, well, really the inheritance model is not well understood by a lot of JavaScript developers. And if you started within the past 3 years, 3 or 4 years, you've probably not really been exposed to it. And you might think that things like classes and the new keyword are how it's kind of done under the hood. And there's really nothing wrong with that per se, but it kind of obscures the true nature of JavaScript objects and how they're created and sort of their prototypal link. And this was probably this whole thing I'm going to mostly be talking about is really the inheritance model. We'll kind of touch on some other things, but it probably would have been better titled JavaScript Inheritance, A Closer Look. And so my real goal for this is for you to kind of take away, if you haven't thought about this stuff, sort of maybe some perspectives or some examples you can look at to kind of get you familiar with how JavaScript operates at this level, and then also to give you some sort of avenues that you can do your own personal study. And this isn't meant to be comprehensive in any way. What it's meant to do is sort of open your mind to the realms that you have available to you when working with JavaScript, because it truly is a pretty cool language once you kind of get into the nitty gritty of it. And it's going to be fairly short. It's meant to be sort of, digestible. And as I think Maggie was mentioning, if you have questions, feel free to just kind of, interrupt during the presentation, because it might be easiest to address them as we're going over the examples, because I just have a number of examples and I kind of want to just talk about them. All right, so what are we talking about when we're talking about objects conceptually? What we're speaking about is a collection of related data and or functionality. That's generally what you can think of when you're talking about an object. You might see the term associative array online, and they're generally referring to the same thing. And the MDMN docs would describe it as a dynamic bag of properties. So if we take a look, this would be one way to create an object in JavaScript, would be an object literal. And then so what we have is literally just an object created with the curly braces. This is the syntax for it. So if a console.log that, I see that I have that here, we take notice of this proto, which we're going to continually reference throughout this talk. But this is really kind of the baseline understanding of how you work with objects. Of course, you're able to add properties to this. It's a collection of properties and methods. Methods being nothing more than a property value with a function as its value, or excuse me, a property with a function as its value. So for anybody who's confused about the difference between a function and a method pertains to an object, and it's a property that has a function as a value. So you can think of objects as namespaces. We can access things on the namespace with the dot notation, among a few other ways. But this would be kind of the most common way of doing it. So object one would be the namespace, if you're familiar with OOP. And then you can access that namespace with the dot notation. So another way to instantiate an object would be with the new keyword, which you might have seen before. These two are effectively the same thing. If you take notice, let me get rid of that for a minute. These two are exactly the same thing. They both share the same prototype, and this is important because when we're talking about objects, what we're speaking about is all objects barring a few cases, have a prototypal chain. They have a link to a prototype. They're instances of some prototype. Ultimately, almost everything is an instance of object, the capital O object in JavaScript. And then so this is the higher prototype from which most all other elements in JavaScript are derived from, even functions will ultimately come from the object. So the reason I wanted to kind of show you this this other way to create objects is because this really highlights the prototypal nature of them. This is just the first example rewritten. This object.create is another way of instantiating an object, but with this you're able to actually provide the prototype. So if we take a look at these examples here, we notice that these two have
Cody, can I ask a question?
Yeah.
What's a prototype?
A prototype. What I'm going to continue to do is talk a little bit more, and it's going to become clear. And what I'll do is after this example, I'll sort of round off a hard definition of what a prototype is. I might even reference MDN docs for that. Okay. So I'm going to circle back around to that. Okay, so another way to instantiate an object would be with this object.create. So what I was referring to earlier with the baseline object, that's what we're referencing here with this .create. I want you to take notice of something. I'm able to create this object. I'm gonna get rid of these two for a moment. So this object has nothing in it. There's nothing in there. But why am I then able to say reference a method here? Well, it's telling me that there's a method on this object. It's toString. It's a function method. If I call it, actually invoke it, it's going to give me the type object. But this is the nature of what prototypes are. I've inherited this object. Object one has inherited methods from its prototype. So if we come here, we see this is a toString method right here on its prototype. And this understanding, what's taking place here, is really the basis for what makes JavaScript so dynamic and powerful, this prototypal inheritance model, because it's different from a class-based inheritance model in a few key things, which we'll touch on slightly. So to answer your question, what is a prototype? A prototype is that which offers its base to instances that come after it. So I can have methods on this object that are not of the prototype. So object one now has an A property to it, I should say, not a method, but it also has access to all of its prototypal properties and methods, whereas the prototype would not have access to the A. So let me see if I can look up okay, so the MDM docs define prototypes as follows. Prototypes are the mechanism by which JavaScript objects inherit features from one another. And that's basically it. It's really as simple as that, but you can do a lot of tricky stuff with them. So, okay. So if we take a look at this object.create method, again, this is another way we can instantiate an object, but we can provide it a prototype. So in this case, what we're doing is we're saying we just want it to have its general prototype object. Sorry. What's going on here? Okay. So notice these first two have the same prototype because these two are equivalent. These two I've highlighted are exactly the same because what we're doing is we're defining an object. We're saying create this object, and we're providing it the base prototype of object. And so we notice that we have the exact same prototype here. well, excuse me, we're defining a base prototype that has a prototype of object. There's another layer of abstraction given to us when we define it this way. But they're effectively the same thing because there's no intermediary, there's no inter-level methods or properties other than the additional layer of proto. So we can access, conversely, if we were to say define just object with null, there is no prototype on it. We notice there's no proto here, so there's nothing it has available to it. So this is the baseline for what I want you to grasp as we move into these other examples. So one thing you might be familiar with, especially if you're working with React or if you've worked with React, is classes, the advent of classes in JavaScript. Classes, they are what are considered syntactic sugar. And if you're anywhere, like I said, if you're a newer programmer, I would consider myself a newer programmer. I've been programming in JavaScript for about 3 years. So I would say if you're around there, you're probably a newer programmer. I didn't realize all of this stuff about this syntactic sugar and how classes are actually just ways to make JavaScript seem more like a true object-oriented programming language. And that's really all they are. They obscure the true functionality and nature of the language itself. But this is what you can do if you wanted to create an object with a class. You could say a class, you give it a constructor. I noticed we got some potential questions popping up maybe. And then so you could say this dot sound equals bark. So this is the constructor function for the class, and we're providing a method to this class. So if I say Bill is my new dog, Bill then has access to talk. Bill equals, this is where you would have to use bind in order to get access to this. So a downside to using classes is that it really obscures the context of the word this. This line 78 here will not work. This will, because the word bill.talk is not going to be referring to this instance of this object. And that's why when you're working with React, you'll tend to see, this dot bite, bark or whatever equals bind this, however it does. I can't pull it off the top of my head. But the point is if you're trying to access the methods of it, you would have to bind this to it. And this would be the way you would do that in just plain JavaScript. So I guess what you need to take away from classes is these are syntactic sugar, and you have to do kind of workaround stuff in order to get JavaScript to function back in the way it was intended to do, So if we look at this same example under what's considered the constructor pattern, what we see here is the same type of thing, only becomes slightly more obvious, I guess. What we have here is a function dog. Take notice of the capitalization as well. Class dog, function dog. This is not mandatory, it's convention. When you have a constructor function or a class to capitalize, it's just convention. And so we have this dot sound equals bark. So we're saying when we create a dog, this dot sound equals bark. So const dog, oops, that is not what I want to show you there. Again, if we go ahead and console.log this, I'm the prototype of object.get prototype of Bill. Bill is my new dog here. We can see that its prototype is a constructor, as well as the prototype object itself. And then if we just log Bill itself, we see that we're showing bark with prototype, constructor, prototype. So what's taking place here is that this itself, I think, adds to the confusion about the prototypal inheritance nature. These constructor functions were, again, sort of ways to make JavaScript seem more object-oriented, and these the class-based system is syntactic sugar to this. So just bear that in mind. One of the problems that you'll run into with the newer things with the new fat arrow functions is it messes around with the context of this. So if you'll notice, it no longer works. Dog is not a constructor. This .sound is not working because it's not going to refer to the dog as it's instantiated. And there's a whole bunch of understanding behind that I don't think I'm well versed enough to articulate properly, so I won't even try. But one thing you can understand is when you're defining constructor functions, you can't use the fat arrow function because it messes with the binding of this. So in steps, what I consider to be the more appropriate JavaScript way of handling this, the factory function. The factory function differs in a few things. It's a function. Dog is set to a function, not necessarily a constructor. And what we're doing is we're returning some functionality, or we're returning potentially a new object entirely. Notice I'm instantiating two objects here, Bill and Ted. Those are my dogs. I'm just setting them equal to dog, and I'm invoking it, so that's going to give me the functionality here. Bark, bark, I'm able to access these without binding this. That's the key I think you should take away versus, say, a class, is you don't have to bind this anywhere when you're doing these factory functions. What makes it a factory function is that you're returning functionality or an object. You're returning the stuff as opposed to instantiating it with a class. To kind of round off some of the takeaway here, a class versus an object, or classical inheritance versus this kind of prototypal inheritance, is that a class is a blueprint. A class describes, the example I found online was, a class is a blueprint and the object would be the house. So the instances of that class would be the house. The class itself is a blueprint. You can make many houses off of a single blueprint. A prototypal inheritance model differs in that the prototype itself is a working object. We can prove that because we're able to, say, access methods on that prototype, like we showed up here with the toString stuff. So if I have this here, these are two objects, and I can say new object, get rid of this, object.toString. Oh, object one. As a function. So what has taken place is that the inheritance chain, what the browser did, or what ran my code did, was it looked on object one. It says there's no toString method here. So then it goes to its prototype, and then it checks if it's there. It is there. But if it wasn't there, it would go up the prototypal chain up until it got to null. And if it did get to null and it was not able to find what you were looking for, that's when it would return undefined. So again, I guess that's the main difference to understand when you're talking about classes versus objects. Prototypal inheritance is that the prototypal object itself is a functioning, usable object, whereas the class is just a blueprint to create them. All right, this example I think highlights some more interesting functionality. So in the previous example where we were, say, returning functionality of the dog by invoking the function itself and assigning it to a new variable, we can create this sort of constructor pattern, but just by assigning it to the object we want to be the prototype. So notice I have a rectangle here. The rectangle is an object with a single method of area. That area, all it does is return this times width times this times height. So if I wanted to instantiate from that object, this is a functioning object. I can call this and invoke it. I can use it, I should say. If I wanted to instantiate a further object so as to maybe extend its functionality, which is what you're doing with objects anyway, what you're doing is extending the prototypal functionality on your objects that you create. I can just do, again, object.create. This is again where you would provide the prototype. I can just provide it the prototype that I want. So if I notice here, where am I doing it? I'm assigning a new object. I'm saying, okay, object.create, give it the prototype I want, which is rectangle, which has a single method, and it's taking this dot width times this dot height. So I'm assigning those, I'm clumsily attributing those properties to rect with rect.width equals 5, rect.height equals 10. So now area should work. I save it and it's 50. That much seems okay. That's apparent. That's clear. That makes sense. And I think this is actually, it appears to be a really solid way to start writing JavaScript, but it's still clumsy because what if I had 15 objects and then I wanted to create rect1, rect2, and I'd have to assign them all as such. Well, from here, we can take this idea of having this prototype that has methods attached to it and just add that functionality into the prototype itself so this create functionality. So whereas up here, what I did was I said const object.create and gave it the rectangle prototype. This was outside of the rectangle. What I'm doing is moving this functionality into the rectangle object itself. So now this rectangle object has two methods available to it, area and then create. So create does a few things. It takes in width and height, and it's setting the prototype to itself. So that which is output from this function has a prototype of itself, the rectangle. That's what this line is stating. And we're assigning height and width to it dynamically as we create it, and then just returning that. So this line right here, these lines right here, I should say, are equivalent now to this line right here, rect equals rectangle.create. Then I'm providing it the height and width. I can console.log this. I'm getting my height and width provided, but if I take a look at the prototype, I can see that I have those methods available to me on the prototype. So I can do things like call rect.area, and it should provide me with the proper area. But again, the prototype of the prototype is nothing more than object.prototype, the great ancestral object.prototype, which has all of its methods available to us. So this is the prototypal chain here. If I was to say rect.toString, what's taking place is we're looking on rect itself. Is toString on rect? No, it's not. Height and width are. Okay, well, what's on the prototype? Area and create. So toString's not there. Well, is it on that prototype? Yes, it is. toString, so it returns the value. And this is the prototypal chain. If I wanted to access the prototype in my code, it could be a little bit confusing. So I think I'll go to the next example for that. So you'll take notice of this sort of proto __. This is what this is the browser's default variable that it uses what this is the browser's default variable that it uses to describe the prototype. Shouldn't have got rid of this, sorry. So that is not standard. That's not in the ECMAScript standard. That's not part of the documentation of ECMAScript. This is a browser convention, and it's just widely used. I don't know what that means, if it's going to change in the future or what, but just bear that in mind. This is not of ECMAScript. This is a browser thing. This __ proto. How you might access the prototype via your code would be then to reference that variable. So again, we have a constructor function where all we're doing is we're saying new f, my object is equal to new f, and has two properties to it, A and B. Notice f.prototype here, I'm setting B to 3. So if I console.log object here, notice object has A1, B2, right? It has a prototype. We won't look at that quite yet. But what I'm doing is assigning this object has this here, its prototype as something else. I'm now here saying, okay, well, f.prototype, B, I want to actually set that to 3. So if I console.log object.b, what we get is the expected output 2. But if I console.log object proto.b, because I reassigned it to 3, we get 3. This is a very powerful bit of functionality to kind of grasp. And this concept is called property shadowing. What we're doing is shadowing the property value of an object with its, over its prototypal object. And it's from this that you can do certain things. Let's say you have a general base object that has a certain set of functionality, and you want to have a more specific object obtain most of that functionality, but overwrite some method to do something different. You can do that with this sort of structure. So let's see, the last thing I got here for you would be, oh, this is the same basic thing. I just wanted to give you another example of having this right here be of that sort of condensing all of the create functionality into the object itself, which we're just doing the create function. We're attaching it as a method to f. F is nothing more than an object. And then we can instantiate new objects from it with just f.create. And then now we have all these new objects. B is not defined. Three, 4. Let's copy that for a second. Okay, so I think that's really the majority of what I wanted to get across, and maybe from here we can sort of open it up for questions to maybe talk about specifics of what we just went over. If there's less, if anybody's unclear of the kind of prototypal chain inheritance, how it's functioning, I think now would be the time to start talking about it. I'll see what's in chat here.
Yeah, feel free to ask questions within a chat, or you can even unmute yourself and ask questions.
Is class syntax a feature of ES6? It is. I think it was ES6, 2015, I believe. And again, it's just syntactic sugar. All of these attempts to make JavaScript more object-oriented in its look and feel were attempts to popularize it back when it was coming out. They were really kind of placating to Java developers and the like, and it really just kind of obscured the nature of how it works. This prototypal inheritance is different than class-based inheritance, and there's a lot of nuance to that. But once you understand the differences, or you understand precisely how JavaScript's functioning, you can leverage that to do some pretty tricky things. And again, if you're coming from, like, I learned most of my JavaScript learning React kind of in tandem, and I was, it was a big of a stretch to really grasp more of the JavaScript, true JavaScript prototypal model of inheritance. Syntactic sugar, yeah. Blueprint. Yeah, I didn't, like I say, I didn't expect this to be comprehensive. There's only so many things that I think we could talk about to make it digestible. But again, the goal for this was to steer you in the right direction to where you can begin really deep diving this stuff yourself. So a couple resources that you can have, like I was doing a bit of research just to sort of talk about this in a little bit more of a detailed manner. I use this really, really old book, JavaScript, The Good Parts. I don't necessarily recommend going and buying it. If you can get it for cheap, maybe. It's fairly old, but it has some really good, bits to it, nuggets, I should say. That would definitely make you a better JavaScript developer if you absorbed it. And then, of course, the online ebook that you can find, eloquentjavascript.net. That is hands down probably one of the best overall resources that you can go through outside of the docs themselves. And then actually there's an extremely good blog post on all of this that I think people would do well to go over. It's if you're new, it talks about some stuff in a way that maybe be confusing to you if you consider yourself more of a junior as far as your JavaScript understanding. But I will find that link and post it here in just a moment. So is Node.js as backend written in OOP often among enterprises? I notice React is now shifting towards functional. Yeah, I think React, I think they'll be the first to admit that their whole adoption of the class was probably one of their bigger mistakes ultimately. But is Node.js as a backend written in OOP? Well, it's kind of a weird question. When we're talking about object-oriented programming, for the most part, we're talking about it's four my kind of main tenets: encapsulation, abstraction, and then I don't know. There's two others that I forgot about, but you're already using them for the most part. JavaScript does this with things like closure, the idea of closure, and abstraction. So I guess an abstraction would be maybe this create method. But there's no real JavaScript isn't a traditional real object-oriented programming language. You can just kind of take that paradigm and utilize its principles. So kind of bear that in mind. Yeah, and I'm looking for that blog post. I really think for anybody who's interested, it would be an extremely valuable read.
Cody.
Yeah.
I found JavaScript for the good parts free, I think, and I posted the link in the chat.
Oh, nice. Yeah, if you can grab it free, it's definitely a good pickup.
So it's in the chat if anybody want to see it.
Bear with me just a moment. I should have had this on hand. All right, I got it. We'll drop it in Discord as well. Yeah, actually, I'll just, since I pulled it up on my laptop over here, I'm just going to go ahead and drop the blog post I was referring to in the Discord link as well for this workshop channel. If again, I said it was short and sweet, and I apologize, it's not much longer, but I think that's all I got for everybody. I can link this index HTML file if people want to look at these examples and kind of go over them and play with them. But other than that, if nobody has any questions, I think.
I have one. You said you posted the blog in the Discord?
Yeah, I'm going to actually do that right now. Boom.
And if somebody did want the links to the what you were just talking about, how would we go about getting that?
You mean to the blog post I was referring to?
No, you said, I think you're referring to the code to play around with it.
Oh, yeah. What I can do is just put this file, this index file in the Discord as well. It's just a single file, so I'll just link it for download.
Which channel is it going to be in the Discord?
I'll put it in the October workshops 1021, where we're posting everything for this workshop right now. So yeah. So yeah, it'll be in there right now. I got the link to the blog post in there, and then like I say, I'll also put the this HTML file in there as well. Well, I'm gonna go ahead and call it.
Well, thank you, Cody. This has been a very informative workshop. And thank you everyone for attending. That's it. Have a great day.